So we'll start with analog recorders. So there are a number of analog recorders. We can classify them into three different types. You have the graphic recorders, you have the oscillographic recorders, and you have the magnetic tape recorders. So there are a number of types of analog recorders, and we are actually going to be looking at only some select recorder types. So starting with the graphic recorders, a graphic recorder simply displays and stores data in the form of pen and ink. Simply displays and stores pen and ink record of data. So what will be the basic elements of a graphic recorder will be, there will be a chart, fine. A chart will be used for displaying as well as in this case storing. Whatever you are drawing on the chart, that also remains as a mark on this chart permanently, you can say. Stylus, stylus is what will be creating the mark on the chart, and it will be moving proportional to this. Proportional to source and paper, so you can have some source that is actually driving the stylus, and it will be proportionally moving as per whatever information it has to store on the paper. And thirdly, you can, in this there will be another component, the interconnection between stylus and source of information. So a graphic recorder is simply a chart type display wherein and you are using simple pens. They may be using ink to store information on the paper, and the elements of this graphic recorder include a chart, a stylus, and the interconnection between these two. Now there are again two types of graphic recorders. Strip chart recorders, and secondly you have the XY recorders. So the difference between these two that strip chart recorder is actually nothing but an XT recorder. That means we'll be actually plotting any function. You can say that function is X versus time. But in case of XY recorders, what we are doing is we are plotting x versus y. That means one independent variable is being plotted against another independent variable and not against time. So strip chart recorders, they are also known as XT recorders, while as XY recorders they are simply used for plotting two different types of functions, a dependent variable and an independent variable in this case. Now among these, again we are basically going to be looking in detail about the strip chart recorders. First of all, the construction. This here shows a strip chart recorder. There are a number of elements of the strip chart recorder. So construction wise, what are the components of this? One, you will have a roll of graph paper. Now I'm not going to be discussing in detail what the paper will be here, because we'll be looking at the mechanisms, and there I'll be telling you that you can be using different types of papers. And so this is your graph paper here. There will be a roll of this, a large roll of graph paper. There is a drive system that actually is this paper drive mechanism that actually is rotating this paper, and that actually is moving this paper. And normally 1 to 100 millimeters per second is the speed with which the graph paper is moving. You have the stylus, or what you can simply say as the pen, and you have the stylus drive system now. And you have the range selector. So range selector will actually decide what will be the range within which this the minimum and the maximum values within which this system will be recording any sort of information, and that will actually go to the control circuitry of the drive system, of the stylus's drive system. A stylus drive system can actually have it will have a lateral motion, or it can have a linear motion, a curve motion, that we'll also be studying later on. So accordingly the drive system will make the stylus to rotate or move across the length and the breadth of this chart paper. So the different components here, there is a chart, there is a chart driver or the paper driver. You have the stylus, simply that is a pen or anything else. We'll again look into that. And then you have the driver circuit for the stylus, and you have the range selector for the stylus that will actually decide the minimum and the maximum of the information that can be stored. Now the operation. So there are three things happening in this. One will be the paper drive mechanism, how the paper is driving. Second one will be the marking mechanism, how actually the stylus is moving. And there will be then the tracing system that we have to discuss in these operations. So the paper drive system, there's not much to it. It moves either horizontally or vertically, and mostly the design is that the paper is driven vertically only. In some cases you can have an horizontal motion of the paper. In most of the cases in strip chart recorders, the paper is driven vertically. and it is will be moved at a uniform speed. There is no we do not vary the motion of the paper. We mostly fix the motion of the paper, and as said that it can be anywhere between 1 to 100 millimeters per second. And again, most of the times the paper drive mechanism will use a synchronous motor is used for driving the paper, right? So appropriate mechanical arrangement will be placed along with the synchronous motor for driving the paper. The paper is driven vertically in most of the cases and at a uniform speed. There is not much to the paper drive system. It is a very fairly simpler job. Now secondly, we have the marking mechanism. How actually the stylus will mark on the paper. There are now a number of techniques for the stylus to be marking on the paper, and first one is, say for example, we have marking with an ink filled stylus. So in this case we'll be using simply a pen or an stylus that will be filled with ink, and the ink is held under gravity or the capillary action that you understand, and this stylus will be made to move across the width and the length of the paper and make an impression on the paper. So in this case we are using simply ink. So the paper that we'll be using will also be a simple paper. So this type of mechanism for marking is simpler, it's easy on the paper, and it's not much costly. And most of the cases the ink that we prefer to use is red. We can use other colors also, but in most of the strip chart recorders the color that's visible is red, and we prefer to use a red colored ink. A simple mechanism, use a simple pen filled with ink and held under gravity and capillary action, and you can simply make it have a mark on the paper. So this is low cost, and the paper used will also be simple paper. There is also, with this mechanism you can actually make the stylus move at different speeds easily. You do not need to bother about because ink is almost instantaneously generated from the pen, so you can increase the speed with which the stylus is moving, and you can use a wide range of speeds for the motion of the stylus. The disadvantage with this ink based mechanism is that if you hold it for much longer the ink will get clogged. Also the ink gets spattered at higher speeds. The ink will get spattered. That is the disadvantage with the ink filled stylus. So we have some other mechanisms, say for high efficiency, for higher speeds extra. Say you have one that is marking with the heated stylus. So what we do in this case is we use a paper that is coated with thin white wax on black base. So your stylus in this case will actually be heated, so you cannot use a simple pen. So you are making a trace So in this case, in the marking with the heated stylus, what we'll be using is the stylus will be heated to a certain temperature. Since the paper is coated with a thin white layer of wax and on a black base, so as soon as the stylus moves on the paper, the wax will get melted. It will produce a white impression, white impression, and that impression can be used. That impression can be mm, that impression actually gives us the recording or the visualization of whatever the information was that the stylus was trying to convey. So this is how the mechanism of marking with the heated stylus. Use a paper coated with thin white wax on a black base. The stylus is heated. So this mechanism can be used for higher speeds. There will not be any spattering of the ink, as was the case. There will not be any spattering at higher speed. So that is the advantage with this system. But the thing is, this is costly. You are using a special type of paper. You are using a heated stylus. So all that thing adds to a cost. And you have third mechanism. Let me first let you know. There is a chopper bar. There is the electric stylus. There is the electrostatic stylus. And there is the optical marking. So in the chopper bar, what we do is that we are applying pressure to the stylus to create an impression on the paper. So this type of mechanism is pretty slow. It will produce only impressions at regular intervals. It will not create a continuous impression on the paper. So this chopper bar can be any sort of device that actually is pressed onto the paper at regular intervals. You cannot keep on the system pressed onto the paper continuously. It can cause the damage of both the stylus as well as the paper. So it will leave impressions at regular intervals. So accordingly, we need at times certain types of record wherein we are not having a continuous. We do not need a continuous monitoring of a graph with respect to time. We need a discrete nature of information. So in such cases, chopper bar is used. It is however slow and again costly. Then there is the electric stylus. Again, we in this case we'll be using a paper sensitive. So this is working under pressure. This is paper sensitive to current. So through the stylus will be passing a current, and the paper in this case will be used of conducting nature, that will be sensitive to current. And whenever the stylus comes in contact with the paper, the property of the paper will be that it will leave the impression only at the point of contact of the stylus with respect to the paper, as soon as the current flows through the paper. So this again requires a special arrangement wherein you have to pass the current through the stylus. You have to use a special type of paper again that is conductive actually in nature, and a certain impression is created onto the paper due to the contact of the stylus with respect to paper and flow of current through that very point of contact. So it will leave an impression. This particular mechanism is actually very quite fast, because current is flow of current is much more faster as compared to the flow of ink. Then you have the electrostatic stylus. Now this type of paper will actually be using paper sensitive to high voltage. So in this case we'll be using a stylus that will create a high voltage discharge onto the paper. The paper will be sensitive to the nature of the voltage and create an impression accordingly. Also there is the optical marking. So you can actually focus a beam of light onto certain photoconductive papers, you can say light sensitive papers, and that will create a an impression on the paper. So these different types of markings can be used in different types of applications. In most of the cases, in simpler applications, we will use an ink-filled stylus. But wherein we need higher precision, we need higher speed, we need a certain type of discrete nature of the waveform. So we'll be using different types of marking mechanisms in different types of application areas. Thirdly, so we have seen the marking mechanism, we have seen the paper drive mechanism. Now how will the stylus be driving? The stylus will be driven from the information and the control circuitry that is actually calibrated using a range selector switch, and accordingly there will be a trace that the stylus will be creating. So the tracing system can also be of two types. One, you'll be having a curvilinear system, and second, you will be having a rectilinear system. So in case of curvilinear system, what we do is the stylus will be mounted on a pivot and it will be moving through an arc. It will not be moving just linearly, it will move through an arc. Stylus moves through an arc. Across the full width of the chart paper, an arc will be created. It will be moving in such a fashion. So if the stylus will be making actually a full range recording, what we'll be having is that we'll be getting a curve using this type of tracing system. A curve will be drawn. So in a curvilinear system, a stylus, instead of moving linearly, it will be moving through an arc along the width of the trace paper, along the width of the paper, and in such a case a curve will be drawn on for a full range recording. A curve will be drawn. So this type of mechanism can be employed for driving the stylus. The problem with this mechanism is that the recordings that will be obtaining from the on the graph paper will be difficult to analyze. It will not be linear variation of the waveform with respect to time. It will be a curvilinear variation of the waveform with respect to time. So what happens is this type of mechanism is difficult to analyze. For when it will produce an impression on the paper, the user will not be able to analyze this without knowing the knowledge of the tracing system, knowing the knowledge about the mechanism through which the tracing system has passed. In case of rectilinear system, you will be having simply a perpendicular or a parallel line drawn along the axis perpendicular to the time axis or parallel to the time axis. Line will be drawn. So it will actually show a linear variation of the waveform with respect to time. In such a case, the stylus will be making a linear variation of linear movement along the graph paper. So it will cover the entire length of the paper, and such a system will be easily analyzable. We can easily analyze the system and we can draw the conclusions as a user. So this is all about the magnetic the strip chart recorders, not the magnetic, the strip chart recorders. So we have to study two more types of recorders. One is the magnetic tape recorder and the UV recorder I have, and we'll do that in the next session.